Hi, this is Vijayaraghavan. I have created a face mask detection system with my friends as an internship project. We have been doing internship for the past 3 months in the Indian service and developed this project. The name is Masdet. These are the libraries which have been used: TensorFlow, Keras, Immutals, NumPy, OpenCV Python, Matplotlib, and SciPy. We developed our project using MobileNet, which is an alternative way of CNN. With this MobileNet, we created a model which is a base model. With its output, we passed it into another model, head model, and produced the output. I'll explain it deeply soon. This is the overview of the dataset. We collected this from the Kaggle. Without mask we used 1918 images, and with mask we used 1915 images. Since the count is much less, we used image data generator. I will show the overview of the dataset. We used two directories, with mask and without mask. With mask has 1915 photos and without mask has 1918 photos. Now let's get into the pre-process section. First, initially I have been imported all the necessaries. I will come to this whenever needed. Init LR, which is known to be the initial learning rate. Hence, the learning rate I have been used is 0.0001. Lesser the learning rate, loss will be calculated properly so that we can get the better accuracy soon. I have used 20 epochs and the batch size is of 32. And I have been declared in the directory of the dataset and variable categories with two names, with mask and without mask. And then here I am looping into a picture and turning into an array. Since all the machine learning and deep learning techniques can be implemented with an array structure, and appending it data and corresponding category to the label. Since the label is of words like with mask and without mask, using label binarizer, we are converting those into values like ones and zeros. This label binarizer is imported from the sklearn. Here it is, which will convert the label names like with mask and without mask into the ones and zeros, and then it is passed into a numpy array so that it is converted into an array. Now it comes to the training and testing of the part. Here the total data set is not used for the testing. Only the 20% of the data set is used for the testing, and the remaining 80% is used for the training. Since our data set is so less, it's around 4,000 photos. It's comparatively less, so that we have been used image data generator, which will convert the images into different versions like a rotation with the specimens of like rotation range of 20, zoom range of 0.15, with shift of 0.2, shear range of 0.15, and etc. And now came the mobile net, the base model. We have been created the base model using this mobile net. This 224 and 224 is the height and width of the image, and this 3 represents the color parameter, which is RBG. And then the output of the base model is passed to the head model, and then the model is flattened, and then it is passed to the 128 layers with the activation function of ReLU. This ReLU is an go-to function for the non-linear use. Dropout function is used to overcome the overfitting of the model, and the softmax function, and this two layers, and the output is of like with mask and without mask, so that the output and the final layer is of two, and on that layer the activation function and we used is softmax. We use the Adam optimizer here so that to compile our model. Then we have been trained our network, and the model is being fitted, and then the predictions have been made, and the predictions have been made with the using predict function, and then the report have been generated, and the model have been saved to the disk in the format of h5. Then the accuracy and the losses have been plotted, and the image have been saved. Now let's train the model. Now it's have been started to training. Yeah, our dataset training have been completed. We can see here all 20 epochs have been completed. The loss have been gradually decreased and the accuracy have been gradually increased, and finally it has an accuracy of 0.99 and the final loss amount is 0.0264, and the model have been saved. And the plot has been also plotted. We can see it here. We had a great training accuracy and the loss has also been decreased. Now we completed the mask detection training. Rather, we didn't have a face detection. So I have a face detector model here, which is I'm gonna use it. Now let's integrate the face detector model and the trained mask detector to the real-time camera. Now we are going to create a detect mask video, a Python new file, and the necessary packages have been imported. And then the face detector model have been imported and it is loaded with the usage of OpenCV deep neural network function, and then the mask detector model have been loaded to the Masdet variable, and then the camera is initialized using video stream, and each frame in the video is of 400 width, and this image and the mask net and the face net have been passed to the detect and predict mask function, and this function is about here. It has certain manipulations and it returns two values, locks and threads. Locks represent to the location which is of the x and y coordinates around the face, and the prediction gives the accuracy of the wearing of mask. If the value of mask is greater, then it shows us the person wears the mask. If the value of the mask is not up to the level, then it shows us the person has not wear the mask. These are the color parameters which we have been used. If we are wearing mask, it will shows a green color. If we are not wearing the mask, it will shows us the red color. And these are the probability of to check whether how much percentage, how accuracy, whether the person wearing mask or not. And then these are implemented, and then a rectangle shape is shown around the face, and then the with mask or no mask have been written on the frame, and these are the, now let's see the output. Yeah, now let's run the application. Yeah, now without mask, I have the red color around my face, no mask of 100%. And now I'm gonna wear the mask. You can see the difference, it has been shown the 100%. Now I'm gonna quit the application. This is the standard output we got. With mask, it's about 99.79%, and without mask, with red color around my face, 100%. Yeah, thank you.